Hello everybody, welcome to today's webinar. My name is Chris Harrold. I'm the Yara product manager for the UK and Ireland, and today's webinar is all about looking at foliar nutrition of maize and also grassland. There are some CPD points for joining today's webinar. The codes are there at the bottom of the screen. There's 1 point for basis and 1 point for Enroso. I will put those codes back up at the end of the presentation, just in case anybody's joining us late today. But what are we going to cover? Well, we're going to begin with a short poll. There'll be just 3 questions about how you're going to be managing or looking after your maize and grassland crops this spring. So we'll start with those, and we'll share with you the results of the poll at the end of the slides, and hopefully you'll find that of interest to yourselves as well. Then we'll move into looking at the basics of nutrition with relevance to maize and grassland. And I think that the reasoning to sort of set the scene for the whole webinar is to really say that what we can do with foliar applications of nutrients is not going to be a silver bullet. You know, we will only be applying with a foliar application grams or perhaps hundreds of grams of a particular nutrient in that application. And clearly crops, and particularly the ones we're talking about today, will be removing hundreds, well, tens if not hundreds of kilograms of particular nutrients in the crop. And we'll talk about that in a bit more detail as we go along. So it's important that we get the basics right, and I also think that sampling is important as getting all of that crop nutrition program right from the start. So that we'll talk a little bit about soil sampling, organic material sampling, which I appreciate this year those 2 elements have probably already been done with reference to this season, but I think in the context of what we're talking about today, it's still relevant to touch on that. But also other sampling involves obviously checking the crop during the growing season. And then if you identify that there's an issue with a particular nutrient or several nutrients from that tissue analysis, it gives you a base to make your recommendations and take action on what the crop needs in the way of rectifying that deficiency. And then a practice that's being done even more now than it perhaps ever has been is to sample the crop at the end of the season. And obviously that tells you 2 things really. It tells you, have you achieved what you set out to do with regard to the nutrition of the forage at the end of the season, but also if it shows you that you haven't quite hit what you were hoping to achieve in that regard, and yield as well when you combine the 2, it helps you hopefully for the following season. You can make adjustments to your crop nutrition plan for the following season based on that end of season analysis that you've taken. Then we'll go on to look at the actual nutrient requirements of maize. So we will look at the macronutrients, but primarily look at also the inclusion of micronutrients in maize. We'll look at the foliar applications and the products within our portfolio that fit into the maize crop. And that also includes biostimulants. Biostimulants are increasingly being used in crops, not just maize, but particularly we have seen benefits of using one of our products, a biostimulant product, in maize crops. We see some variability with that, I have to say, from one season to the next, but we've now got several years worth of data where we are starting to see some positive results from one year to the next. So we'll talk about those as well. And then we'll move on to grassland foliar nutrition. Now, I appreciate foliar nutrition within grassland is not necessarily commonplace, but there are occasions when tissue analysis has identified that there could be some benefit in applying some foliar nutrition to a grassland situation. And given the amount of rainfall that we've had this year, certain nutrients are showing up as being deficient this year. Then we'll conclude with our key recommendations for this season for our portfolio of products for these two crops. And then we'll finalise this evening's webinar with a Q&A session. And please, if you have got any questions that you've got during the presentation, please do put those into the chat, and I will do my best to answer those questions before we finish today. If I do happen to run out of time and I haven't managed to answer all those questions, I will endeavour to get back to you all on an individual basis without answers to those questions after today. I should also have said at the start, we will be recording today's webinar. So if any of you need to leave early, or there's some points that you want to revisit having seen the presentation, the whole webinar will be recorded and will be on our website over the next few days. Okay, so we'll move on now and we'll start with the poll. There are 3 questions, and I'll put the first one to you now, and I'll just give you 30 seconds or so, if you wouldn't mind, and just see what your response to that is. Are you growing maize for animal feed or for use in a biogas plant this year? And you may be growing it for both end uses. So I'll just give you a few more seconds to answer that. As I said, we'll share the results of these at the end of the presentation, so we can have a look at those then. Okay, right, thank you for that. I think everybody's there. So I'll close that one and we'll move on to the next one, which is, are you planning to use biostimulants on your maize crops this season? Yes, no, or maybe. Okay, thank you very much, and I'll close that one. And the final one. Have you used tissue analysis of your grassland to investigate any micronutrient deficiencies? Yes or no? Okay, brilliant. Just a few more seconds and then I think everybody's had opportunity to answer that. Great. Well, I appreciate that. Thank you for your feedback on those. So we'll revisit those at the end of the presentation. So let's move on now. So I mentioned at the start, I wanted really just to spend a few minutes just talking about getting the basics right first. Foliar applications of nutrients have their place, and if there is a particular deficiency that's been identified, then you can make that judgment about what materials and nutrients need applying. But we are only going to answer deficiencies of small amounts. If we haven't got the right nutrition set up in the first place, and clearly this applies to all crops, it's not just maize and grassland, but I thought it was important to sort of start here in today's presentation. And you'll have seen this image before, I'm sure. This is Liebig's barrel, his law of minimum, and when one particular element is missing, then you are unlikely to achieve the yield potential that the crop has got. And of course, it isn't just about the nutrients. It can include other things as well, such as the availability of water, the temperature, the soil conditions, etc. And particularly this year, after we've had such extreme weather over the last 8 months, then there will be elements of this that will be at play this year as well, just as well as the nutrient availability. And I suppose really the reason for putting this slide in here is just to sort of emphasize the importance of pH and getting that right as well. I appreciate it's quite late in the season to rectify issues like this, but after all that wet weather, the issues around pH, we could end up with some particular acidity, surface acidity, particularly after that excess winter rainfall. And we know there's an interaction between the availability of some of these nutrients and the pH of the soil. And we'll come back to that a little bit in more detail later on. So analysis, I think, is where we need to just think about. It helps us make those decisions, helps us get the basics right, and we can make a more informed decision when we've got the facts in front of us. You know, analysis will allow you to manage your crops in an efficient way, a cost-effective and a sustainable way. And soil analysis is the starting point, and as I know, at this point in the season, in the middle of May, the soil sampling of this year will already have been done, but it's important. It gives you that baseline chemical reading. It'll also give you the physical attributes of the soil as well, and more so than ever, we are now looking towards understanding the biological status of our soils, perhaps more than we ever used to do. Organic manures or organic materials are used extensively in maize crops and obviously on grassland as well, and they're an important source of nutrients, and I think we've become better equipped at being able to utilize those materials in recent years. Some of that's been driven by legislation, but also some of that, I think, more recently certainly has been driven by the cost of buying in inorganic fertilizers. And clearly, we're not just talking about farmyard manures and slurries anymore. You know, digestates are more commonly available now, and also composts. I know a lot of farmers and growers are now making use of compost as a way of making a more consistent material for use on the land. And I think it's important that we consider analysing those organic materials. Yes, we could use book values from such as RB209, and that's a good starting point. But because of the clearly the variability of these materials from one farm or one field to the next, I think it's important that we consider taking the time to analyse those products or those materials individually, and then we've got that better understanding when we're putting our crop nutrition program together, that we take that into account. You know, we can analyse those materials, understand the total nutrients that are in those, but I think it's becoming increasingly important to have a good understanding of the availability of the nutrients within those materials. You know, what of those nutrients are going to be available to the crop this season? Clearly, you know, some materials will have a higher availability to the crop this year than others, and some will have a greater availability to following crops. And I've made those mistakes before by overestimating the availability of nutrients in some of these materials and found that we've under-fertilized the crop later on in the year. So I think, you know, when we're taking this whole approach to getting it right from the start and taking the time to analyze these organic materials is important. And then if we've done all that, we've analysed the soil, we've analysed any of the organic materials we're putting into these crops, it makes sense to continue to analyse the crop during the growing season. And I'm not just talking about sampling, you know, for leaf tissue analysis during the growing season. Clearly that's important, particularly if you feel you've got a deficiency that you need to address. But also, I think increasingly we're starting to analyse the crop after harvest, and then therefore knowing something about how the crop was yielded. When we've got the analysis back from the forage, then we can make an informed assessment of how the crop's actually fared this season. And if it hasn't achieved the yield or the quality that we were hoping, then we can make adjustments for next year based on that analysis. So there's a whole range of analysis there, and I just wanted to share with you some of those options that the land crop laboratories can offer with regard to those particular times of the season you might be looking to do analysis. And because we're often in these crops that we're talking about using them for livestock nutrition, then it's important to consider when you're sending these samples into the lab that you ask for livestock specific analysis, and that is possible to do. For example, with soil analysis, you could ask for an animal health soil analysis. So it's doing the usual analysis of the soil sample, but it also gives you the nutrient levels for those that are particularly vital for the health of livestock. In organic materials, you've obviously got options for an analysis of solid and liquid materials and give you a full picture of the nutrient content. During the season, if you're going to do leaf analysis, then it's worth considering asking for the animal health leaf analysis. It doesn't just test for the main nutrients, it will also include nutrients that are vital for the health of livestock as well. And then finally, at the end of the season, if you want to analyse the forage itself, there are different options for example, grass, fresh grass or grass silage. So they're just some of the options, and I'm sure that if you had any queries, the lab would be happy to help pass on any information that you might want on those. Okay, so we've sort of talked about getting the basics right first. If we start moving now into talking about maize specifically and what are the key nutrients for an optimum maize crop. Well, clearly we want to talk about the macronutrients first, so the N, P, K and magnesium, but there are also a couple of micronutrients, zinc and also boron, that I think are worth touching on as well with reference to the maize crop. So we'll come back to the micronutrients a bit later on. When you look at how much nutrient you will remove with a maize silage crop, it's quite interesting how much you will remove. For example, if you took nitrogen, this is all based on kilograms per ton of dry matter, you would remove 14 kilograms of nitrogen per ton of dry matter with a maize silage crop. With regard to potassium, you can see you will remove a significantly large amount of potassium with a maize silage crop. I don't want to sort of belittle the relevance of the other elements like calcium, magnesium and sulfur, but you can see what I'm getting at, or what I sort of the point I was making at the start when we talk about the macronutrients. The crop requires those nutrients in tens, if not hundreds of kilograms to have a successful crop. And we'll see when we get to the micronutrients how that compares. This slide is showing the leaf tissue analysis for maize that we received into the lab at Pocklington over a number of years. I haven't circled the nitrogen on the left there, but you can see that 40% of the samples sent into the lab were showing some level of nitrogen deficiency. But particularly when you look at phosphorus, you can see we're over 60% of samples showing some level of deficiency. Nearly 70% were showing potassium deficiency, and over 75% were showing magnesium deficiency. So that's quite a high proportion of samples received showing some form of macronutrient deficiency, which is perhaps suggesting we still aren't getting it quite right from the outset with those particular nutrients. And then if you move to sort of the right-hand side of the slide, when we're looking more at the micronutrients, then I've just circled the boron and the zinc. I'm not ignoring the others, and obviously manganese there, you can see roughly sort of 30%, a good 25% anyway, were deficient in manganese. But the boron and zinc, you know, we're nearly sort of 30-35%, showing some level of boron and zinc deficiency over those years. So that's why I want to sort of touch on those elements in a little bit more detail today. So if we just start with the macronutrients and nitrogen itself, and clearly nitrogen is an important nutrient for any crop, not just maize. But I think this year, with the long period of rain that we've had from autumn through winter and into spring, you know, the excess winter rainfall chart that the AHDB put up, you can see particularly down the sort of eastern side of the country, we have had, you know, excess winter rainfall above the norm in a lot of those areas. Interestingly, when you looked at the deep N sampling results for this year, they've tended to suggest, yes, they are lower than the average, but perhaps not as low as we thought. My theory behind that is perhaps due to the above average air temperatures that we've experienced over that same period. We haven't had a particularly cold autumn and winter, or early spring for that matter. And perhaps there's been a bit more mineralization of nitrogen within those soils. Having said that, I think it's important that we don't underestimate or perhaps overestimate the availability of nitrogen in these soils in these spring crops that we're talking about today. Because I think we might find we have to be topping these crops up if we overestimate what's actually there. Moving on to phosphorus now. I showed you in the bar chart at the start of this section that phosphorus removal by a maize silage crop isn't quite as great as it is for nitrogen and potassium, but it's still significant when you multiply it up on the tons removed. And we know that phosphorus is not a mobile nutrient within the soil. In fact, it's particularly immobile, and it's not unusual to see that very distinctive purpling effect that you see on the imagery that I've got on the slide there. I'm sure some of you have seen that before. And we know that there are several factors that influence the availability of phosphorus in the soil. Soil temperature is one. The relative availability of phosphorus within the soil increases with soil temperature. And clearly, you know, as we get to this point in the season, middle of May, soil temperatures are rising and have been rising rapidly, particularly in the last couple of weeks with the better weather. And that will help availability of phosphate within the soil for sure. But there are other factors. Soil pH, and I alluded to soil pH at the start about getting the basics right. You know, we know that higher pH alkaline soils, the calcium ions will lock up the phosphorus, and the converse of that is the lower pH acidic soils below sort of 6.5, then the phosphorus will get locked up by the aluminium and iron in those particular soils. And crops with poor rooting, because it's not a mobile nutrient within the soil, you would need proportionately more roots within the soil to absorb what the crop needs of phosphorus compared to a more mobile nutrient like nitrogen, for example. Now, hopefully soil conditions have improved in recent weeks so that root structures and the soil around them is in good order. But if crops have gone into less than ideal conditions, which is possible this year, then there is a chance that the root system's been compromised and the crop's ability to take up the phosphorus that's in the soil has been compromised. In that case, we may have to look at further applications of phosphorus, and we'll talk a little bit more about that shortly. Potassium. Potassium's particularly important for water regulation within the plant and cell turgor. And the uptake of potassium is particularly high later on in the season. As I mentioned in that bar chart at the start, the crop removal of potassium is significant in a crop of maize. So it's important that we make sure that we've sufficiently supplied the crop with that potassium in the first place, and also bearing in mind the availability of potassium for the following crop. You need to take that into account with the crop removal from the maize crop in this case. Availability of potassium can be limited by acidic soils, pH below 6, and there can be some leaching of potassium through the soil profile. So again, those on particular soils like the sandy ones, the lighter soils, with all the rainfall we've had, the likelihood is there's been some leaching of potassium this year. And finally, the last macronutrient I want to talk about today with regard to the maize is magnesium. Magnesium is a key component of chlorophyll, and therefore it's important for the photosynthetic capacity of the crop, the greenness of the crop, if you like. And the nutrient is quite mobile in the plant, and the plant will, if there's deficiency there, you'll start to see it on the older leaves, as you can see in the picture on the right of the screen. The crop will mobilize the magnesium within the leaves to the new growth, and hence the older leaves start to almost prematurely senesce. So it's important that we have plenty of magnesium available for the crop. Availability, again, can be reduced on acidic soils below sort of 7, 6.5 pH. And it's important that we take into account where we might be applying large quantities of potassium, that we could potentially inhibit the availability of magnesium where those higher applications of potassium are going on. So that's just important to take into account. There is an interaction between those two nutrients. And this is just sort of re-emphasizing that point I was making about the availability of phosphate with regard to the roots. The plant will take up phosphorus from the soil solution, but only when it's very close to the root itself, which isn't, relatively speaking, you can see because of the higher mobility of nutrients, particularly in this case the nitrogen, the crop can more easily take up that nutrient because of its mobility compared to, say, something like phosphorus. And that's important when we talk about applications of nutrients to maize and getting a good nutrient use efficiency. How much of it could we potentially be wasting? Clearly, we establish maize on wider rows, 50 to 75 centimetre row widths. And if we're going to apply those nutrients that the crop needs in a conventional way, if you like, using a fertilizer spreader, and the weather remains dry or the soil remains dry, potentially those nutrients are not going to be utilized by the crop, certainly not during the early stages of the season. So is there a better way of utilizing the nutrients? And yes, there is, and that would be by placement. And I know this is now commonly done in maize by placing nitrogen and phosphorus within the rooting zone. That's sort of either below and to the side of the seed or directly below the seed. And you can see benefits from that in improving the nutrient use efficiency from placing that fertilizer. Particularly important for phosphate. So why might we be talking about foliar applications of nutrients to maize? Well, this slide is basically just showing the demand or the cumulative uptake of those particular macronutrients we've just been talking about. We tend to put a lot of the nutrients on at the start of the season. We place some, we top them up early, so we've got the crop fully fertilized right at the start of the season. But as you can see, as with most crops, the requirement or the uptake of those nutrients is greater later on in the season. And if we haven't sufficiently supplied the crop with those key nutrients earlier on, there could potentially be some potential for deficiency later on in the season. And we'll come back to talk about that in a little bit more detail shortly. Yara Crop Boost is our foliar option for these later applications. If we've identified that there is a limitation from any of the particular nutrients that we've measured from a leaf analysis, or we feel we've compromised the crop, it's got poor rooting for whatever reason, it may be that a foliar application of something like Yara Crop Boost can bypass that issue around the rooting and directly put it into the leaf. You may remember a product called Yara Maize Boost. Well, this is exactly the same product in all but name. We were finding that Maize Boost as a product was being used on lots of other crops because of the benefits it was delivering. So we changed the name to Crop Boost, but that's all that was changed. The formulation and the analysis have been retained. It is simply just a change in name. And where we've looked at foliar phosphate on maize, we have seen benefits. As I mentioned, if the root structure has been compromised and the crop is not being able to uptake sufficient phosphorus through its root system, then a foliar application can help overcome that sort of negative soil interaction. And we've measured up to 10% increase in root and shoot weight where we've applied those foliar applications of Crop Boost. And you can see that in the pictures on the slide here. The right-hand plant in both cases has had that Crop Boost, and you can see increased amount of rooting, but also an increase in above ground biomass as well. And that's those kind of responses we've seen for a number of years now. So moving on to the micronutrients, I mentioned that at the start, and you can see here straight away in this chart that the removal of these micronutrients is straight away just in grams per ton of dry matter, rather than the kilograms per ton that we saw with the macronutrients. Interestingly, when you look at the micronutrient removal in forage maize, iron shows up as being a significant one relative to the others, but also manganese and also zinc. When you multiply that up in the total offtake per hectare, that will start to add up to certainly hundreds of grams, if not in iron, maybe even thousands of grams. But interestingly, when you look at the micronutrient removal of grain maize, the emphasis switches a little bit more towards the boron and the zinc that I've mentioned at the start. I appreciate that grain maize is increasing as a crop, particularly in the south of the country. Farmers are finding that they can successfully now grow grain maize now. I know that wasn't always the case, but perhaps with climate change, we might see even more grain maize grown in the coming years. But interestingly, you see it's all relative really, the grams of removal, but this is obviously grams per ton now in the grain rather than grams per ton of silage in the previous slide that I showed. So just really wanted to talk about the zinc and the boron in the context of maize. You know, zinc's important for auxin production, and again, there are potential issues around its availability. depending on soil pH. And again, there's another interaction of note here between high phosphate soils limiting the uptake of zinc. And again, if we're talking about maize, and I just showed you a slide where we're placing potentially large quantities of phosphate into the seedbed, we could potentially see an issue around locking up or making the zinc less available where we've applied those high levels of phosphate. The symptom, as the photograph shows you there on the screen, is that sort of pale or even yellow tram lining effect on the leaf, on the most recently emerged leaf. And we can easily rectify zinc deficiency, but if it is showing up to be a significant deficiency, the impact on yield left untreated can be quite significant. And when you look at the zinc uptake by maize, as the crop moves from that sort of vegetative stage to the more reproductive stage later in the season, you can see that the uptake of zinc starts to increase significantly, and the content, or the cumulative content, is more in that grain than in the leaf and the stalk. So it's important to make sure that we supply the crop with sufficient amounts of zinc later on in the season. Moving on to boron. Boron's one of those nutrients that I think we need to concentrate on a little bit more. We're starting to see boron deficiency show up in tissue analysis of just about every crop now. It's a very mobile nutrient within the soil. So again, this year, with the rainfall that we've had, there are quite likely going to be boron deficiencies in various soils this year, particularly the lighter, sandier soils. But there are also issues with boron availability on high alkaline soils. We know that historically. But boron's important within the plant for the transportation of calcium around the plant, and therefore the sort of structural integrity of the plant. So, and it's not just with regard to that boron has an effect. It's important in the pollen tube formation, and therefore pollen viability and sort of fertility of the plant, if you like. And if the plant is not sufficiently supplied with boron, you can see malformation in the growing point as well. So I think it's an area that we need to perhaps consider looking at, is the application of boron to maize if we've identified that there's potential or have identified a deficiency there in the crop. And when you look at boron uptake by maize, it's not quite the same chart as I showed you for the zinc, but you can see a similar sort of pattern, if you like, that the requirement in the grain is there, and the uptake, the cumulative uptake, shows you that it's greatest later on in the season. So I'd like to move on now to talk about biostimulants and their place in maize. And biostimulants are becoming increasingly important in complete crop nutrition programs. We're seeing their use in many crops now in our climate, and their ability to improve a crop's tolerance to abiotic stresses. And by that I mean stresses that could be something like heat stress, or the extremes of temperature, too hot, too cold, water stress, too much, too little, but other factors as well that may have brought on a stress within the plant, such as an application of a herbicide, for example. They're all areas where biostimulants have shown some benefit when they've been applied. And where they've been applied and help reduce that stress, we see improvements in nutrient use efficiency. And where we get that improvement in nutrient use efficiency, we get an improvement in yield. So it is an area that we are looking at as a company in more detail, and I just want to share a few results and a bit more information about our use of biostimulants in maize over recent seasons. So BioTrack is the product I'm going to be talking about. It's a complex formulation of nutrients, but also bioactive components, and that comes from Ascophyllum nodosum, which is a seaweed algae, and the combination of those elements has been shown to improve the crop's tolerance to those stresses that I've talked about, and therefore an end result of improved yield. The nutrients within the product include boron, zinc, nitrogen, and some potassium alongside the biostimulant element, if you like. And just to share with you some yield results from our maize trials over the last few years. This first one was from 2021, and I'm looking at fresh weight tons per hectare here. And this was when Crop Boost was still called Maize Boost. So you can see in the chart there, 5 litres applied in the orange did give us a little lift in yield, but the addition of 2 litres of BioTrack to that Maize Boost gave us a significant lift up. And in fact, in that particular year, the BioTrack itself gave us a reasonable lift in yield over the untreated. We repeated that work in 2022, and as is often the case with trials, we saw very little difference that year. There was an increase from the Maize Boost that year, but no extra benefit from applying the BioTrack with the Maize Boost. And actually the BioTrack on its own that year, there was a slight increase in yield, but not a significant one. And then if we look at our results from last year, 2023, there was a good uplift from the Crop Boost at 5 litres to the hectare over the untreated, albeit not quite significant. But actually, when we added the 2 litres of BioTrack to that Crop Boost last year, that was the yield increase there was a significant yield increase. And actually, the BioTrack on its own at 2 litres a hectare, that was also a significant yield increase. So we will be continuing our work looking at BioTrack and the Crop Boost in maize trials this year to continue to build on our data set, basically. But we feel there is some benefit from using the BioTrack in maize alongside the Crop Boost now. Just to sort of finalise on the maize, I would like just to talk about nitrogen timing. As I mentioned, we tend to put a lot of our nutrients into maize at the start of the season, and clearly the demand for some of those nutrients doesn't peak until later in the season when the crop moves towards more of a reproductive stage. And you can see here basically what we're saying is that there's still an awful lot of nitrogen requirement for the crop once it gets to that stage. And we do have a solution. If we feel that a foliar application of nitrogen is required, then we have a product for that situation called Yara Vita Safe N. It's a concentrated liquid nitrogen designed for those foliar applications. And although it's quickly absorbed by the crop, around about 25% of the formulation, the nitrogen in that formulation is present in a slow release form. So you're getting that sort of longer lasting feeding effect. And our recommendation for Safe N is to apply 20 litres to the hectare at that pre-tassel stage. And we have got some trials data looking at Safe N. This was from some years ago, I appreciate, and it was in combination with Maize Boost, but there was a yield benefit from combining the 2 applications. And then we had, from the same trial that I showed you previously from 2023, there was also just a Safe N application in that trial on its own. And you can see there 20 litres applied was giving us a yield benefit, albeit in that case, again, not quite significant when you put the stats on it. But if I was to put that into a program, our core program for maize, then we would be looking at 5 litres of Crop Boost. It gives you that readily available phosphate application along with potassium, magnesium and zinc. And when you combine it with 2 litres of Biotrack, we've seen a cumulative benefit from applying them both at the same time at that 4 to 8 true leaf stage. And if there is a demand or a requirement for a top-up of foliar nitrogen, then there's always the safe N at 20 litres to hectare, as we've just talked about. Okay, so moving on to the foliar nutrition of grassland. And I think with regards to grassland, the same principles around getting the basics right are just as relevant here as they were when we were talking about maize. You know, it's a balanced crop nutrition approach, and the micronutrients play their part just as much as they do in maize in grassland. And the most important micronutrients on grassland yield are copper, manganese and zinc. Other micronutrients which do play their part but aren't necessarily essential for grass, but are for the grazing animals that are utilising that grass, include other nutrients like sodium, selenium, and you would probably even include cobalt in there. Now, if we look at the micronutrient uptake of grassland, it's quite interesting to see how that varies from how the grassland is being managed. So this is just 2 different examples comparing an intensively grazed dairy situation to an extensively grazed beef scenario. And you can see that there is significantly different uptakes of those particular micronutrients in grams per hectare per year, depending on how the crop's being managed. Just would like to point out about copper. If the grassland is being grazed by sheep, then obviously we'd want to be careful about not applying excessive amounts of copper due to the issues that can cause to sheep if they're grazing that sward. If you look on some of the work that was done some years ago on the effects of micronutrients on grassland yield, you can see in this particular work that was done actually in Finland that the inclusion of manganese and zinc on that crop, along with all the other nutrients that were applied, there was a yield benefit from ensuring that that crop had those extra nutrients. And our go-to product in grassland currently is CropLift Pro. It is a foliar applied wettable powder formulation that contains N, P and K, magnesium and sulfur, but along with a range of trace elements. Because of that formulation, you get a very immediate boost for the crop, particularly if it's under stress, but also if you've analysed the sward and found that there is a requirement for those nutrients. So our recommendation would be to apply 5 kilograms to the hectare of CropLift Pro as soon as growth starts in the spring, or you've identified that there's a deficiency from analysis. Repeat applications can be made if that's necessary, but all I would say is probably not relevant now because hopefully most stock has been turned out. But if you are applying CropLift, it's probably best to leave a 7-day gap between that application and turning out the stock. Of interest perhaps is that it is physically compatible with a number of the grassland herbicides. So I appreciate in some cases you won't necessarily be going through your grassland just with a foliar nutrient application. It's possible that you may be going through with a herbicide, in which case you could mix CropLift Pro with the herbicide, but I would always point you towards the tank mix website if you've got any specific tank mixtures that you were interested in putting on the grass. Just to sort of put a little bit of a financial look on CropLift Pro applications, if you were to apply 5 kilos to the hectare, the cost would be roughly £25 a hectare, including the cost of the application in that figure. If hay was valued at £80 a tonne, and you may challenge me on my values here, then you would just need just over a third, 0.3 of a tonne to the hectare of yield increase in the grass to cover the cost of the crop lift. If you were applying it to a silage grass at £35 per tonne, you'd need about 0.7 of a tonne to the hectare increase in silage to cover that cost. And if it was a grazing grass and we valued that grass at £90 per tonne of dry matter, you'd need just under 0.3 of a tonne to the hectare to cover the cost in that situation. So just that's sort of bringing me towards the end of my slides. I just want to sort of recap on what we talked about with regard to the maize and the products that we have in our range that have a place. We talked about Yara Vita Crop Boost at 5 litres to the hectare, applied at the 4 to 8 true leaf stage. It gives you that readily available phosphate along with potassium, magnesium and zinc when the crop needs it. We've seen useful uplifts in yield over a few years of trials now, including the biostimulant product BioTrack at 2 litres to the hectare in combination with the crop boost. And finally, on the maize, if there is a requirement for a top-up of nitrogen, then we've got Safe N, which can be applied at 20 litres to the hectare pre-tassel. And finally, on the grassland, we've just covered it, Yara Vita Crop Lift Pro at 5 kilograms to the hectare as soon as growth commences in the spring, or you've identified that there is a deficiency based on the tissue analysis that you've taken. So yeah, thank you for joining today. That's taken us just about to 7 o'clock, and it just remains for me to say good luck with the rest of your season with your maize crops and grassland crops. It's been a challenging year so far. Let's just hope it starts to continue to improve as we go on. But thank you again, and enjoy the rest of your evenings.